By the end of this video, you'll be able to solve this question, which is given to us as calculate the amount in mole of carbon dioxide that occupies 20.0 centimeter cube at 25.0 degrees Celsius and 100.0 kilopascal. And also this question, calculate the molar mass of gas if a 500.0 centimeter cube sample at 20.0 degrees Celsius and 101325 Pascal has a mass of 0.666 gram. So before we solve this question, let me introduce you to the ideal gas equation, which is given to us as PV is equals to nRT. So let's define all the letters here. P stands for pressure in Pascal. V stands for volume in meter cube. N is amount of mole in gas. R is the universal gas constant, which is the same as 8.314 J K minus 1 mole minus 1. And T is temperature in Kelvin. So pressure must be in Pascal, volume must be in meter cube. N is calculated as mass over molar mass, and R is given to you in the chemistry data booklet for your curriculum, which is 8.314 joules per Kelvin per mole. And temperature must be in Kelvin. And the exam is usually in degrees Celsius, but you have to change it to Kelvin by this formula TC plus 273.15. So the hardest aspect of this formula is changing to the right or to the correct unit. So remember, pressure must always be in Pascal. It's sometimes it's given to you as kilopascal, but change it to Pascal. And volume must be in meter cube. So if it's given to you in the dm cube form, divided by 10 to the power 3 or by 1000, or if it's given to you in the centimeter cube, divided by 1 million or 10 to the power 6. And amount in mole, this can be calculated using n is equals to m over molar mass over molar mass, and temperature must be in Kelvin. So change the degree Celsius to Kelvin by adding 273.15. So let me do a derivation of one formula. So the original formula we have is PV is equals to nRT, but mostly when we are asked for the mole, this is how we rearrange it. N is equals to PV over RT. That's for N. Sometimes you'll be asked to calculate for the molar mass, and the N is the same as mass over molar mass is equals to PV over RT. So to get the molar mass, crisscross, this will be mRT is equals to mPV. M becomes mRT, small mRT divided by PV. Let's look at this example. As always, the first thing is changing to the right unit. So for pressure, we have 100 kilopascal. Remember, it has to be in Pascal, so it should be 100,000 Pascal. And for volume, it is 20.0 centimeter cube. So you have to divide it by 1 million or 10 to the power 6. So that will give you 0 cancels 0. 0.2 times 10 to the power -5 and meter cube. And for the temperature, it's given to you as 25 degrees Celsius. So you have to change it to Kelvin by adding 25 plus 273.15. So that will be 298.15. So now we have all of this, we can calculate them all. So the original formula, always start from this formula. It's given to us like this. So N becomes PV over RT. So in this case, N is equals to P is 10 to the power 5 times V is 0.2 times 10 to the power minus 5, and R is 8.314. Remember, this is given to us, the universal gas constant, times T is 298.15. I intentionally left out the units. So for N at the end, you'll get 8.08 times 10 to the power minus 4 mole. So this is why we'll get at the end of the calculation. Let me know in the comment section. So for the second example, we do the same thing. First, identify the units and correct them to the right unit. So for volume, we have 500 centimeter cube. So you have to change this to meter cube. By what? By dividing by 1 million or 10 to the power 6. So that will give you 0.5 times 10 to the power times 10 to the power minus 4 meter cube. And the temperature will be 20 degrees Celsius going to 200 plus 273. That will be 293.15 Kelvin. And the pressure thankfully is given to us as Pascal, so you don't need to do anything to it. And the mass is given to us as 0.666 gram. It's in the right unit, so you don't need to change it or do anything. So in this case, we're asked for the molar mass. So instead of using the original equation, we can use the one we derived here, which is molar mass is equals to mass times RT divided by PV. So we use this formula. Molar mass is equals to mass times RT over PV. So that would be 0.666 times 8.314 times 293.15, all divided by 101,325 times 0.5 times 10 to the power minus 4. So that will give you your molar mass to be 32.01 gram per mole.